Hi, this is Kenneth Wong for DE. Welcome to another episode of DE News Roundup. This is for the week of November 16. Some types of 3D printers produce potentially dangerous emissions, including ultrafine particles and volatile organic compounds, according to the research published by Underwriters Laboratories and Georgia Institute of Technology. According to the study, many desktop 3D printers generate ultrafine particles while in operation. These particles are the size of nanoparticles and can be inhaled into human pulmonary system. The research also identified more than 200 different volatile compounds released during the operation of some 3D printers. The current phase of the research is focused on fused filament deposition printers, commonly used in offices, libraries, and schools. Factors such as nozzle temperature, filament type, filament and printer brand, and filament color, and even extrusion temperature may affect the level of emission, the study states. The study also includes some good suggestions on how to minimize the emissions impact. Suggested methods include operating the 3D printers only in well-ventilated areas, setting the nozzle temperature at the lower end of the suggested temperature range for filament materials, standing away from the operating machines, and using machines and filaments that have been tested and verified to have low emissions. For more on this, read DE's article titled UL Study Identifies Hazardous 3D Printing Emissions, now online at DE 24/7. That's digitalengineering247.com. Autodesk Annual User Conference for this year, Autodesk University 2018, is wrapping up now in Las Vegas. At the show, the company highlighted how generative design is integrated into the Autodesk Fusion software product, a cloud-enabled design solution that includes CAD, CAM, and simulation. Generative design software uses a combination of time-tested simulation methods and machine learning in the background to generate optimal shapes based on users' input such as loads, stresses, and materials. One of the hiccups in this approach is the computer-generated shapes often turned out to be impractical or impossible to produce using traditional methods such as milling or machining. According to the show's keynote, the company is now adding support for more types of manufacturing constraints, adding 2 and 2.5-axis machining to the existing 3D printing support, 3 and 5-axis milling support. That means the shape generated by the Fusion software is now more suitable for those production methods because the software's algorithm will consider these requirements, what works and what doesn't for these approaches in its shape generation procedures. I also attended the conference, and I will be filing my report with all the news and product announcements from the show floor, so come back to DE 24/7 next week. This week, cloud-hosted PLM vendor Arena Solutions just bought Omnify, another vendor in the same market. This comes soon after Arena announced it is opening offices in Austin, Texas, and Suzhou, China, pointing to the company's growth. The new branch in China will support software development efforts at its home office in Foster City, California, the company clarifies. Arena attributes its growth specifically to the IoT sector in its announcement. Omnify is based in Andover, Massachusetts, with a large customer base that includes electronics, medical devices, aerospace and defense, and telecommunication markets, customers that will soon become Arena's customers. Another point of synergy between the two companies is both offer PLM solutions that are web-based, cloud-hosted, making their offerings complementary. The PLM market is dominated by a number of large players, including Dassault Systems, Siemens PLM Software, PTC, SAP, and Oracle. Companies like Arena with cloud-hosted, easy-to-deploy, lower-cost PLM solutions are particularly attractive to small and mid-sized firms that feel the larger PLM systems are overly complex and too costly to deploy and maintain for what they need to do. The Arena-Omnify merger signifies the PLM market consolidation cycle that once led to the emergence of the current top players and now also happening among the mid-range providers. You can 3D print replicas and game avatars, but can you 3D print a radio frequency amplifier complete with circuitry and conductive materials? The question has been settled by Nano Dimension, the company that makes a 3D printer called Dragonfly. 3D printers can print in a variety of soft, stiff, and even metallic materials. Some can also mix different materials in a single print job to produce objects like shoes with different textures and stiffness in different parts. But printing small objects with embedded electronics and circuitry brings the technology to a whole new level, opening the possibility that in the future, some consumer goods with electronics may not need to be assembled but instead printed as a single consolidated part. The Nano Dimensions project to print RF amplifiers was done in collaboration with Harris Corporation, a company that supplies electronics, communication systems, and space and intelligence systems to government, military, and commercial customers. The company reveals that they use the Dragonfly Pro printer to print a functional radio frequency amplifier as a single print, and then components were manually soldered to the PCB, or the printed circuit board. That's all for the week of November 16. For more news, go to DE247. That's digitalengineering247.com. I am DE's Senior Editor Kenneth Wong. See you in the next episode.